Welcome to Module 2 on 279W, Clackamas Community College, and we are going to do some hands-on Microsoft Windows Server 2016. In this particular module, we're going to look at Chapter 3. In Module 1, we covered Chapters 1 and 2. So we've got some objectives to take a look at. We're going to look at Server Manager, how to manage a server, install and remove server roles, and some best practices, and we're going to take a look at some hardware as well. So let's take a look at the roles. So when you go to Server Manager, you install either a role or a feature when you go to add on something to the server that's not already installed when you first install the operating system. So there's a difference between roles and features. Typically, roles are going to be add-ons that affect everybody in a domain. Whereas features are things that are going to affect just the computer itself. So for instance, if I were to install a feature, I might install a telnet client. Well, that's only going to affect the server itself, so that's why it would be a feature. But a role, I might install Active Directory domain services or file and print services. Those are things that are going to allow users to have more security or ability to access resources on the server. So those are my version of the difference between a role and a feature. So there's two common roles for 2016. You've got file and storage services, and that basically allows people to connect to the server using, say, shared folders, that kind of thing. And then you've got print and document services, where you can set up printing from a shared print server, and that's one of the things that we'll be covering in Module 5. Hardware devices are made up of lots of different things, but the most common ones can be the disk drives, controllers, adapters, keyboard, pointing devices such as a mouse, and also a monitor. So when we plug in a device into the computer, Server 2016, along with other versions of Windows, have what's called plug and play, or PNP. That's the ability to automatically install everything, such as drivers and background files and things like that, as soon as you plug a device in. For this capability to work, PNP must be built into the device. And the BIOS, or now we refer to it as the UEFI, must be able to communicate with that device. So if you plug in a device that neither the motherboard nor the operating system can recognize, then that device isn't going to work. You'll have to put in drivers, upgrade the UEFI. Older computers tend to use what we refer to as a BIOS, or basic input-output system. PNP eliminates a lot of hours of time that we used to spend a long time ago in adding devices to a computer. So even a CD-ROM, for instance, back in the late 90s, early 2000s, you couldn't just plug it in and have it work. You had to download drivers for it and install the drivers, say, from a floppy disk. And then you could get the CD to work. So this is what our control panel looks like in Windows Server 2016. Of course, this is the black and white version of it, and it pretty much looks the same as Windows 10 or even Windows Server 2012. Not a lot of difference there, but Microsoft is slowly moving us over to the system icon. So a lot of things that we could manage in control panel before are going to be managed through the system icon until eventually the control panel becomes barely useful or even not useful at all. But that'll be years before that happens, and Microsoft is doing this a little bit at a time. Here we have the computer settings. So under control panel, you've got, on the control panel, you've got administrative users, administrative tools, I should say. You've got a lot of different things. This is the expanded view rather than the simple view that you saw here. If you click on where it says category, it says view by category, and you change that to large or small icons, then you're going to see this view where you see administrative tools, you see all the different icons that you see here, where you can more easily get to them. I prefer this view better than the simple view myself. It's just easier to find things. Device Manager still is the same as it was in 2012. Used to check for resource conflicts, looked at, allows you to fix devices that may not be working properly. Maybe you've got a driver problem, you can update the driver. Maybe you've got a device disabled, you can right-click on it and choose Enable, and various other troubleshooting types of things. Driver signing is something that came out around 2003. Prior to that, Windows would just take any driver that you would install onto a server and say this is fine. But with all the malware that's out there, sometimes device drivers come with viruses and other malware. So Microsoft came up with this driver signing type of feature, which says basically if the device driver has been signed, then Microsoft will trust it. And of course, in order to get that sign done, they'll need a certificate, they'll need to pay Microsoft some money, things like that. So as long as it's signed, that means it's verified. Microsoft will allow that to go in without any kinds of errors. It'll just work. However, if the driver is not signed, it will give you an error. Now, back in 2003, it just wouldn't even install it. You'd have to go in and make changes to the local security policy. But in 2008, they loosened that up a little bit and said, yeah, we'll let you install it, but then you'll have to get some sort of a warning that pops up. And now in 2016, it's still that same way. So you can go into the group policy and either disable that completely so you don't get a warning, or make it strict again to where it won't even work. So all those are an option based on whatever your security requirements are. So there are some good tools that you can use to fix Windows problems. One of those is the System File Checker. So basically the system, in this particular case, is referring to dynamic link libraries, or DLL files. And these files make various different programs work. They also make hardware work with the operating system. And sometimes they can get corrupted, either by viruses or by just problems with the server. Say maybe somebody unplugged the server or lost power while it was running a particular process. In that case, these DLL files can become corrupt, and then you need to fix them. So if you run the SFC scan now, like you see in the second line, then what it'll do is it'll go through all the DLLs, check to see if they're good, and if they're not, or if they're missing, then it will replace them with good files. So it scans the files to verify integrity, replaces files as needed, and it can scan only certain files if you want to. Like I said, they're mainly used to do the DLL files, which make a lot of what the operating system does work. SIG-verif, or signature verifies systems and critical files to determine if they have a signature. So if you are concerned that maybe some of your files are not properly signed, then you can go in and run this particular command, and it'll go in, create a text file, and tell you which files need to be replaced because they are not verified. After the operating system has been installed, it can be configured to optimize performance. So there's lots of tools to do that. You've got to configure elements such as performance options, environment variables, startup and recovery, power options, and protocols. You can do things like processor scheduling and data execution prevention, and that keeps things from launching and starting viruses as soon as you put them in, such as a DVD. You pop it in, and if you have data execution prevention turned on, you can keep those viruses from starting all by themselves. You can go in and double check that the DVD is properly signed, and you can scan it for viruses, and then you can go ahead and run any executable files. You can also make changes to virtual memory. So by default, Microsoft does this itself through the operating system. But if you don't like the way it's done, you can go in and change it. And we'll be doing that in one of our labs. You also have file caching and flushing. And that goes a little bit beyond this particular course. But it does allow you to cache files if you would like to cache files locally. So if you are a road warrior where you take your laptop out of the office, then you can cache the files onto your computer when you leave. That way you don't have to connect to the server when you go. So those are the things I was just talking about basically. And we've got environment variables. Let's go on to those. Used to tell the operating system where to find certain programs and how to allocate memory to these programs. And you've got user environment variables. This is really helpful. So back in the days of DOS, you would set up your user environment variable So if you were, for instance, going to type a command, it would look for this command in the files that you said were part of this variable. So let's say you kept most of your applications in a folder called applications. So you would add C:\applications to your environment variables. So when you went to go run a command, it would automatically look for the executable you typed in the applications folder. So you can go in and edit those variables so it includes specific folders or excludes folders you don't want it to look for whenever you go to launch a program. This can make the computer or the server run faster and more efficiently. So you can also configure some startup options, which operating system to boot by default. You can set up dual boot if you want. This isn't as typical as it may once have been ever since we came out with virtual machines. If you need to have two operating systems, you just install two virtual machines nowadays. But prior to this, if you wanted to, you could and you still can if you want, but most people don't find it very useful. You can set up a dual boot situation. You also have some troubleshooting in case if you have a failure. You can configure some options. Writing information to a system log can be very helpful, or sometimes what we call a dump file or a mini dump file. You can have whether to start automatically after a system failure, and also write debugging information in the dump file I just mentioned. So what you can do is get a dump file reader, and it can go in line by line until it finds certain keywords in there that tells you why it is that the server is failing. I found this to be very useful for when a server just freezes and crashes and then restarts itself for no apparent reason. The log files don't show up because they don't have a chance to, because the server actually froze. So these dump files you can go in and you can read what happened just prior to the server crashing. And then you can troubleshoot it. You can set a power plan in the power options in control panel. And that power plan can say whether certain things turn off after a certain amount of time. Now on a server, by default, the hard disk will never stop, which is exactly what you want. You don't want all of a sudden the server to try to conserve power because nobody's connecting to it, and then when they do, they can't because it turned itself off. However, you can go in and make changes to that power plan if you'd like. There are three different plans by default: balanced, power saver, and high performance. And typically you would want a balanced power, but high performance is something that you could also do. It makes the hard drives wear out a little bit faster, but you're going to get better performance overall. You can change what the power button does when it's pressed. That's the physical power button on the outside of the box. You can either have the computer or server shut down, do nothing, or hibernate. HyperV, Virtual Switch Protocol. So when you install HyperV, which we're not doing in this class because we're using VMware, when you install HyperV, you can create a virtual switch. So this also happens in VMware itself, but it happens less transparently. You would have to go into the VMware settings and add individual network cards. But HyperV has something a little bit different. It has a virtual switch. And the virtual switch allows you to add which physical network cards are going to work with the virtual network cards. And it also allows you to do something called software-defined networking that says basically you can put several layers of subnets between the virtual machine and the rest of the network. And again, that goes beyond this particular course, but it is something that I have done at previous times to add additional security. The registry is something that we'll be doing in a lab. Basically, you'll be backing up the registry, you'll be going to a registry key, and you'll be exporting that registry key. So it'll be really a useful thing for you to have, especially when you have two computers that are fairly alike. One computer's not working, one computer is, and it may come down to the registry. So rather than trying to figure out how to rebuild the registry keys, you can go to the keys on the computer that's working properly, export them, import them into the computer that's not working properly, and get that computer running again. I've had to do that many times in my career, and it's a very useful thing to learn. Lots of things are included in the registry, such as information about the hardware, information about your profiles, basically everything about the computer when it boots up. It consists of two main files, and they can all be found when you type regedit from a command prompt. and everything about the computer and all the different settings are in there, whether or not to print in color, whether or not an application should launch, say, Microsoft Word with the ribbon showing up, or should it be hidden. So every individual thing can be found there. So as I mentioned, you just go ahead and type regedit, and this is what the registry looks like when you first boot it up. It includes 5 keys. Now, just to let you know how important those keys are, well, one time many years ago when I was in a job interview, one of the questions was, can you name all 5 registry keys? Something I ended up naming 3 or 4 of them, but I couldn't think of the last 1 or 2. So it is something that you should think about when you are in this class. So there are some precautions, some things you need to worry about when you are working in the registry. It is easy to make a change and cause the computer to be unbootable. You may not even realize that you've made it unbootable because it's not going to affect the operating system while you're in it. It's going to affect it after the next time you restart. So you want to, you can back up, and we actually do a backup of the registry in one of the labs, back up the registry, and then learn how to restore it. So it's made up of several different things. You've got the registry keys themselves. So the registry is made up of keys, subkeys, and entries. So these, the 5 that I showed you earlier, these are the 5 what's called Hive keys. So you see it says H key on there. So those stand for Hive keys, the very top of the list. Then after that, you've got underneath it keys, subkeys, and then on the right-hand side, when you open up one of these things, you're going to see information that's basically entries that give various different meaning to those keys, such as whether or not to print in color. Also, the Hive keys are also sometimes referred to as root keys. So sometimes you'll hear it called one thing, sometimes another. So if you hear it one or the other, they mean the same thing. But originally they were called Hive keys, which is why they are referred to as H key when you open up the registry itself. And there's those informational keys, or the values on the right-hand side that I mentioned earlier, that gives specifics to hardware or software. So the H key local machine, that's the main one. If you're ever going to be editing a key, that's going to be probably the one that you're going to be looking at first. It contains information on all the hardware in the server, drivers, version levels, what memory or IRQs it runs in, all that kind of stuff. A few subkeys are stored as a set called Hives because they hold related information. So there's another look at the subkeys that you see underneath the Hive keys, and then their values on the right-hand side. HKey current user contains information about the desktop setup for the account presently signed in. So basically, if I log into the computer and I change the color of the background to blue, and you log in and change it to red, then that information is kept in the HKey current user. And the HKey user's key contains profile settings for all users who have logged into the server. So current user is just for whoever's currently logged in, and then the user's key is for all of the different users. HKey user's root key contains profile information. It's listed under this root key. Within each user profile is information identical to that viewed within the HKey current user. So when you log into the computer, the information from HKey users gets moved into the HKey current user root key. The class's root key holds data to associate file extensions with programs. That's pretty simple. If it sees a .docx, it knows it's Word. If it sees XLSX, it knows it's Excel. So that's all that the class's root key does. HKey current config, information about current hardware, holds information about the monitor type, keyboard, mouse, other hardware characteristics. So that one is also important, but definitely not one of the main ones. So before you work on the registry, you got to back it up. Again, I'll show you how to do that in some of these mini videos in the labs themselves. If the registry is damaged, you can go back to a restore point as well. So you can create a restore point using the checkpoint computer commandlet in PowerShell. Now in Windows 10, restore point is a graphical user interface icon in control panel. But in Windows Server, it's not. It's a command that you need to run in PowerShell. So that would be a nice thing for you to learn to make sure that you know how to go back in time in case your computer becomes unusable. So Windows PowerShell, as we mentioned in Module 1, it's a command line interface or shell, customized environment, and it runs basically scripts. It runs PowerShell scripts, and these scripts are sometimes referred to as commandlets. Some of the tasks that you can do in PowerShell, as you see here, you can basically do anything that you can do in the GUI. You can also do in PowerShell, but you can do more of it. There are more switches, more options, and a lot of commands that are not available in the GUI at all. So PowerShell is far more powerful than any graphical user interface because of that. So this is what PowerShell looks like. Of course, this is a black and white version of it. Typically, it's a blue screen, and you can see the little PS that shows that it's PowerShell. Otherwise, it would just be a command prompt, which would not run any PowerShell scripts. So you can see when we type in dir, you can see a list of all of the different files. So a lot of the commands that work in command prompt also work in PowerShell. Some of the commands are the exact same commands, whereas others are completely different. And there's a list of all the PowerShell commands at Microsoft's TechNet website at technet.com. The only problem is that the same commands that worked in 2012 or 2008, they changed them in 2016, so you have to learn new replacement commands to do the same thing you used to be able to do. It's very frustrating that Microsoft does that, but it's something we live with. We talked a lot about Server Manager. It is the tool that you use pretty much to manage the server. You can add roles, you can remove roles, you can go in and add devices, printers, storage, a lot of things you can do through Server Manager. It's typically the first place that we would go when we want to do anything on the server. All right, so that covers Module 2. So again, you can go into Lab 2 now. You can take the quiz for Lab 2. And in Lab 2's instructions, you will see a lot of links to various different videos that you should definitely check out if you have any questions on how to do something. Each of the videos are usually just a couple minutes, a few minutes long, and you can go in and learn any issues you have. And as always, you can reach me by email or by phone. My contact information is in the syllabus.